Okay, so I'm going to try and solve this problem that is called Homogeneous Transformations with Rotations Practice Problem 1. It says we've got two coordinate frames. We've got robot coordinates in which y points to the right and z points up. And we've got world coordinates, and in world coordinates x goes to the right and y points up. And I also happen to know that the origin of robot coordinate frame is located at 10, 2, -4 in world coordinates. So I'll subscript that with a W. Okay, so let's just start by drawing these two frames. I don't have graph paper, but we'll do our best anyway. I've got my, let's see, for world coordinates it says x goes to the right, so that's x sub world. It says x goes to the right for world coordinates, y goes up, so we'll draw y up, y sub world, and that means if you do your right-hand rule that z for world coordinates comes out of the page. So let's plot the point 10 to -4 and see where we get. Of course, in our class, we always plot on the ground plane first, so that's going to be the xz plane. So we need to go 10 along the x-axis, 1, 2, 3, 4, 6, 7, 8, 9, 10, and -4 along z. So I don't know if you can see this. I'm drawing some little dots there to show you the negative z direction, and that'll be 1, 2, 3, 4. So we're going to draw our little parallelogram here. There we go, and that is the point 10, 0, -4, right? So that's the point 10, 0, -4 in world coordinates, but we want 10 to -4, so we're going to shoot up a perpendicular here, 1, 2, and so the origin of robot coordinates is going to be located right here. And in robot coordinates, we have y sub robot going to the right, z sub robot goes up. And if we do our right-hand rule again, that tells us that the x sub robot axis actually also points out of the paper. Okay, so the next question says, what are the rotations and translations that we need to compute the frame transformation from robot to world coordinates using a moving axis approach? Right, so this is how do we move the robot coordinate frame into alignment with world coordinates using a moving axis approach. So there's, of course, a lot of ways to do this. I think I'm going to do it first by doing my translation to get the origins of the two axes co-located, and then I will do the rotations that I need. So in order to line up the robot coordinate frame with the world coordinate frame, and remember that I'm doing this in terms of world coordinates, I first need to move in the x direction, right? And I need to move this distance here. I don't know if you can see this as I try and redraw. I'm not sure if that's going to show up on the paper, but so I need to move this distance, which is 4 units, and in this case it's 4 units in the positive x direction. So I'm going to do a translation, and we're going to do the x, y, and z translations all in one translation step. So I'm going to translate 4 in the x direction, right? The y direction for robots is, for the robot coordinate frame, is heading horizontally off to the right. Of course, we want to move this distance here, right, from our coordinate frame up to here, which was 10 units. So we want to move a distance of 10 units, but it's a distance of 10 units in this direction, which happens to be the negative y sub robot direction. So we're going to translate negative 10. And then we need to align the up-down direction, right, which in this case is the z sub robot direction. And the z sub robot direction, we need to move down, right, by 2 units. And down is going to be negative z again. So we're going to translate by negative 2. Okay? So there's our translation step. Having done that translation step, we have to believe now that the origin of the new coordinate frame, the translated robot coordinate frame, is laid right on top of this world coordinate frame. And while y world points here, we'll call it kind of z sub robot prime points in that direction, right? And x sub robot prime, because it's not the robot coordinate frame anymore. The robot coordinate frame had its origin here, but now we're doing some translation, so we'll call it the robot prime coordinate frame. And of course the y robot prime coordinate frame is right here. Okay, so far so good. So now if I look, obviously the x world axis lines up with the y robot prime axis, the x robot prime lines up with the z world, and so on. And what I need to do is I need to align the x world axis with the x robot axis, and the well, actually align the x robot to the x world and the y robot prime to the y world, and so on. So what I'm going to do first is I think I'm going to try and line up my, let's see, why don't we align the y-axis, this y robot prime, so that it lines up with this y world, right? So what I'm going to do, in order to do that, I need to do a rotation about the x robot prime axis, right? We're using moving coordinates, so whatever our current version we're at is where what we're doing relative to. So I'm going to rotate about the x robot prime axis. I'm going to say I'm going to do a rotate about x. And of course, this is just rotate x. We don't put any subscripts on that, just like we didn't put any subscripts on the trans. And I want to rotate about that. I need to figure out how do I align this, this y sub robot prime with this y sub world, and the answer is I need to do a rotation in this direction. And that direction turns out to be, if I use point my right thumb along the x robot prime axis, then that tells me that that's a rotation of positive 90. So I'm going to do a rotation of x by positive 90. Having done that, let's see what we get. Let's call this next frame the robot double prime frame. So x sub r double prime is the same as x sub r prime, right? Because we rotated about that axis, so that axis stayed the same. But now the y sub robot double prime axis is the same as y sub world. And the z sub robot double prime axis, that's supposed to be horizontal, is now pointing out to the left. Good? Okay, so since my y-axes are aligned, I think I can just do a rotation about the y-axis, and I should be able to get my x and z axes aligned. So if I look, right now z sub robot double prime is pointing out to the left, and I actually want it to align up with z sub world, which is pointing out of the paper. So that means I need to rotate about the y-axis in this direction. Again, it's a 90-degree rotation, and if I point my thumb along that y-axis, I will see that I'm going to be rotating in a positive 90 again. So I'm going to do rotate about y by positive 90. Right? And once I've done that, then let's see, so my y will stay the same, so let's call it triple prime now. Y sub robot triple prime stays the same. My z sub robot double prime translates into, or rotates into the z sub robot triple prime over here, which lines up with z sub world, so I'm happy about that. And furthermore, my x sub robot double prime is going to rotate around here, so that means that x sub robot triple prime is right here, which lines up with x sub world beautifully. So I think if you look, you'll see that using this moving axis approach, we've ended up with our robot coordinate frame aligned with our world coordinate frame. In other words, we've computed f from R to W, right? So we'll say f from R to W equals this magical thing. Great.